Hello everyone, I'm Amulya PR of Sri Venkateshwara College of Engineering and I belong to the branch CAC AI. Today I'm back with another subject, Advanced AI and ML, and the topic Instance-Based Learning. So let us see the contents of what we're going to learn today. The contents are what is instance-based learning, advantages of instance-based learning, nearest neighbor algorithm, k-nearest neighbor algorithm, distance-weighted nearest algorithm, locally weighted regression, challenges of instance-based learning, applications of it, and the future trends and the research directions. So first, let us see what is instance-based learning. Instance-based learning is a type of machine learning that will focus on memorizing the data rather than explicitly constructing a model during the training. So instead of forming a generalization or an abstraction, this instance-based learning will store the instances of the training data. And this instances which is stored is being used as the training data to make them predictions by comparing the new instance with the stored ones. So the decision for a new instance is it is made based on the similarity to the stored instance and it is often measured by a distance metric. So the approach will emphasize the adaptability and the responsiveness to changes in the data. So this approach will rely on the assumption that similar instance will have similar output. So next, let us see the advantages of instance-based learning. So the first advantage is that simplicity. So algorithms like k-nearest algorithms, like they are simple and they're easy to implement and understand. So next is flexibility. Instance-based learning can adapt to different types of data and problems. So this will include the regression and the classification problems. So there is no need for training data. That is non-parametric. So since the model is not explicitly trained, the instance-based methods can immediately use the new data for prediction. So the next advantage is that it can handle the complex decision boundaries. So it can highly handle the irregular and the complex decision boundaries because it will rely on the local information. And the next advantage is that it is incremental learning. So new instances can be added without retraining the model again. So next, let us see the nearest neighbor algorithm. So the nearest neighbor algorithm is the simplest form of instance-based learning. So this will predict output for a new instance by just finding out the most similar instance in the training data. So this is using its output. So this method will work very well when the data has clear clusters or the patterns, but it will also struggle when there is noise or irrelevant features in the training data. So the computation of the distance between the point and all the instances in the data set is usually done by the identification of the instance with the smallest distance. So this will return the label or the value of nearest instance. So the concept is just that it will predict the class of new data point based on the nearest neighbor of the training data set. So then the metric is measured, like it is measured using a distance metric, and then it is predicted. So next we'll see the k-nearest algorithm. The k-nearest algorithm will extend the basic neighbor algorithm what we saw in the previous slide. So this will consider the k closest instance instead of just one instance. So the prediction is made by aggregating all the outputs of these k neighbors, that is often using a majority vote or a classification or any regression algorithms. So the steps which follows is, so first it will choose number of neighbors, that is k value. So next we will compute the distance of the instance to all the training instances. So the next step is to identify the k nearest neighbors and aggregate all of them to make a prediction, that is to make any average or regression and to make a prediction. So the advantage of k nearest neighbor algorithm is that it has improved stability over that single neighbor approach which we saw in the previous slide. So the challenging part is that choosing an appropriate value for k and also handling the large data set. So these are the two challenges that we face in k nearest neighbor algorithm. So next let us move on to the distance weighted nearest algorithm. So the distance weighted nearest algorithm will refine the k nearest neighbor algorithm by assigning the weights to each neighbors based on their distance to the query point. So closer neighbors are given the higher weights, which will make the prediction more influenced by the nearby distances. So instead of assigning a simple majority vote, so this algorithm will assign the weights to the k nearest neighbors based on their distance. So the steps which will be used to compute the distance weighted nearest algorithm is, so first you need to compute the distance between the query point and all the training instances. And then you need to, second step is to assign the weights inversely proportional to the distances. That is, the shortest distance will get the higher weight. So third step is to use the weighted aggregation of all these to make a predicted output. So these are the three steps to be followed. Advantage of distance weighted nearest algorithm is that it will handle varying densities and it will provide better predictions with neighbors are, when the neighbors are unevenly distributed, it will provide a better prediction. So that is the advantage of this. Next, let us see the locally weighted regression. So locally weighted regression is a type that will focus on a local subset of the data near the query point. So it will fit a regression model using nearby instances. It is often weighted by the distance from the query point. So the steps which will be needed to follow to compute the locally weighted regression is that first you need to identify the instances that are closest to the query point. So all the instances which are closest to the query point will be identified. Second step is to assign the weights to these instances based on their distance. So uh, next step is to fit a regression model using the weighted instances. So all the weights that are assigned in the second step will be needed to fit a regression model, and then use a local model to make a prediction as the fourth step. So the advantage in this locally weighted regression is that it will provide a highly adaptive and accurate predictions for the non-linear datasets. So the main advantage here we can see is in the non-linear datasets. So next we'll see the challenges in the instance-based learning. So first challenge what we face is the storage requirements. So this will require storing the entire training dataset, which will lead to high memory usage. So the storage requirements will be very much high. So the second challenge is the computational cost. So high, it is very much high during the prediction because the distance need to be computed for all the instances. So for each instance, the distance need to be predicted. So this will be using the cost. So third thing is the sensitivity to the noise. The noisy data can significantly impact the predictions that are made. So the next challenge is the feature scaling. So different scale of features can distort the distant calculations. So the next is the irrelevant features. So in case if there are any irrelevant features that are present in the data set, so this will affect the similarity measure that will be calculated. So these are some of the challenges in the instance-based learning. So the next we'll see applications of instance-based learning. So wherever we use it. So first advantage, the application where we can see is the recommendation system. So here we can see where the recommendation system will suggest the items based on the user similarity. For example, if you use Netflix or Prime Video or any such, so it will suggest the movies or series based on your whatever you use or whatever you watched previously. Based on that, it will suggest you. So the next application is the medical diagnosis. It will predict the disease by comparing the symptoms with the historical cases, like whatever the cases it has been studied. So all that will be mapped with the symptoms. It will be comparing the symptoms with it and it will predict. So the next application what we can see is the fraud detection. So this will identify the unusual patterns by comparing it with the past transactions. So the next where we can see is in handwriting recognition or the pattern recognition. It will classify the characters by comparing it with the stored templates. So in pattern recognition or handwriting recognition, we would have trained the model with thousands or a lot of training data sets. So it will be comparing each new data set with, each new instance to the already stored data set. So the next application is the image processing. So classification of image is done based on the pixel similarity. So this is where the instance-based learning can be used. So the next, we'll see the future trends and the research directions. So the first thing where we can see where there is scope for development is the scalability. So developing methods to reduce the storage and computational cost. So hybrid models can be done. So that is combining the instance-based learning with other approaches such as neural networks. We can create hybrid models. So this will be also reducing the scale, I mean the computational cost. So thereby it can be highly recommended in the future. So the next thing where we can see the future trend is by altering the feature selection. Automating the selection of relevant features to improve the similarity measures can be done. So also, as the AI will continue to evolve, the instance-based learning is very much used to play the vital role in solving the complex problems across diverse domains. So that is it. I would like to thank each and everyone for watching the video completely till the end. I also request you to please like the video and share the video amongst your friends. And this will be the last video of this semester. So thank you.